In previous chapter, we briefly discussed about space, dimensions and matter in it. On rudimentary level, we have also seen that universe is made up of space together with matter in it. In this chapter, we are going to learn about reference point, axis and position. This is our first step to manipulate things that we are all surrounded by through the viewpoint of physics. In this video, we are going to learn about very basic elements to get started to dive into the world of physics. As we know that we learn physics to understand the behavior of nature or how universe behaves. So, to start understanding the behavior of universe, at first we should know the behavior of objects around us. And these behaviors in physics include position of an object, its movement, its rotation, and many more things. So, to understand physical behavior of an object, let us go to the space where nothing is there, void and dark all around us. And since we are going to understand the behavior of an object, let us put a ball in this dark space. And of course, a source of light to see this ball. When we put things in space at rest, it remains there forever. It will neither fall down, goes up, right or left. It is the nature of the space that holds the object at rest when it is kept at rest. You may ask here that how space holds an object at rest when it is kept at rest. Some of you may be thinking that it is Newton's first law of motion. But it is not the Newton's first law of motion that makes the ball to be at rest when it is kept at rest in space. It is the law of universe. Newton was the first person who realized this concept and hence this law got the name associated with him. Okay, let's talk about position of an object in space. Position of an object means where the object is kept in the space. So, how can we know the exact position of the ball in the space? The answer is we can't, as universe and hence space is pervaded infinitely. It has no end. We can only determine the position of this ball in our infinite universe with respect to a point that may be anywhere in space. This point is said to be a reference point. A point from where we can measure the distance of the ball at different locations to know its position with respect to that reference point. What if we try to measure the exact distance of the ball from the reference point? For this, we have to understand axis. The reference point is called origin. If we draw a straight line passing through the origin in any direction, it is called axis. This axis is represented as x-axis when it is put horizontal. If we put marks on this line that are equally spaced, then distance between two adjacent marks is said to be a unit distance. You can see that we have marked positive numbers on right hand side of the origin, since it is forward to the reference point, and negative numbers on left hand side of the origin since it is going backward to the reference point. We have discussed about numbers in mathematics. Now, if we put the ball anywhere in this axis, we can accurately measure the distance of the ball from origin or reference point. For example, 2 units, 5 units, -3 units, etc. These numbers are called coordinate of that point. Since balls are kept in single axis, it is said to be in one-dimensional space. Thus, only one coordinate is required to specify the position of an object in one-dimensional space. Let us take a plane passing through x-axis, and the ball can be kept anywhere in this plane. How we can measure the distance of the ball from the origin now? We can only know its distance along x direction, which is 4 units in this case. To know its exact location, we need another axis perpendicular to x-axis, which is called y-axis. And the plane is called xy plane, which is two-dimensional. Now we can accurately measure the distance of the ball. Thus, the distance along x direction is 4 units called abscissa and along y direction is 3 units called ordinate in this case. This is represented as coordinates. Thus, two coordinates are required to specify the location of an object in two-dimensional space. Till now, we have only represented the location of the ball in the form of coordinates. For calculating the magnitude of its distance from reference point, we need Pythagoras theorem, discussed in mathematics. Thus, using Pythagoras theorem, we got the distance of the ball from the origin as square root of 4 square plus 3 square, which is equal to 5 units. What if we move the ball slightly upward the xy plane? How we can specify the location of the ball now? Again, we need another axis perpendicular to xy plane and is named as z-axis. Now, the location or coordinate of the ball can be exactly specified as 4, 3, 5. 4 units along the x-axis, 3 units along y-axis and 5 units along z-axis. Thus, 3 coordinates are required to specify the location of an object in 3-dimensional space. And the magnitude of the distance of the ball from the reference point becomes using Pythagoras theorem in 3D space. Thus, we can determine the position of any point of an object in 3D space with respect to a reference point called origin. And the system we talked in this video to represent the location of any point in 3D space is called Cartesian coordinate system. Summary. In this video, we talked about very elementary behavior of an object, that is its position in 3 different dimensional space: 1-dimensional space, 2-dimensional space and 3-dimensional space. When an object is kept at rest, it remains there forever. We also talked about a reference point and also determined the position of an object in different dimensional space with respect to that reference point. To specify the location of an object in a different dimension of a space, we need different axes. For 1-dimensional space, x-axis; for 2-dimensional space, x-axis and y-axis; and for 3-dimensional space, x-axis, y-axis and z-axis. We also need coordinates to specify exact location of an object and to calculate magnitude of its distance from the reference point. The system we used in this video to specify the position or location of an object in space is called Cartesian coordinate system, where 1 coordinate in 1-dimensional space, 2 coordinates in 2-dimensional space, and 3 coordinates in 3-dimensional space is required to specify the location of an object.